Welcome to Arduino tutorial number 8, hosted by the real Tony Stark. In this tutorial, we'll be covering topics such as switch case, while, and do while. For this tutorial, you will require the following: the Arduino software, an Arduino Uno or other Arduino board, a breadboard, some jumper wires, some LEDs, I'm using 2, 330 ohm resistors and a 10K resistor, and a photocell, and some bubble wrap. Ha. Alright, well, what are we doing in this tutorial? Well, this one, we're going to do something it's a little bit more analog reading, some analog writing, but I figured this time let's try it with a new type of sensor that I haven't done before, which is a photocell. Okay, now what is a photocell? It's kind of a variable resistor, so kind of like the potentiometer, but instead of a dial where you manually control what the resistance is, it's determined by the amount of light hitting this wonderful little surface. So let's figure out how to set up this board before we begin programming. So if you go to the SparkFun Inventor Kit, it is number 6 is the photoresistor. Okay, and we're going to follow along with the wonderful diagrams that they have here to create our circuit. So if you look here, you will see this is the photocell. It is set up so that 2 of its legs are side by side in the board. Now I'm going to set this up somewhere so it's not interfering. I have room on both sides. They put it right towards the inside, so I guess we can do that too. Alright, then they go directly from one leg. Now it's nice because it is not polar, so you can put it in either leg. You get to decide which one. I guess I'm going to just follow directly along. Now they're going right into, I'm going to flip my breadboard around here so it's facing the same way as that. So let's put this photocell in there. They have a little connection going directly into the positive voltage. So that's that red line. So I've got this little connector here from my breadboarding kit. And then from the other leg, it has, you'll see this 10K resistor essentially going to another row and then from there into the ground line. Well, okay, let's just save a trip here. And let's just go directly from this leg into the ground line. It's just a bit of a detour in the way that they do it. So I'm just going to go jump directly across from this other leg over to the ground there. So I'll hold that up so you can see it. Okay. And then, let's make sure we don't lose our other resistor here. Now it's showing some other things. Well, first we know, as always, we need to go directly from 5 volts on the Arduino to the positive line here. We'll take our brown for ground and go direct from there into our blue line on the breadboard. So that's going to ground everything in here, which right now is also our photocell. The other thing you don't want to miss on the photocell is that the same leg that the resistor is hooked up to, you should be hooking up, following this green line here, should go over to an analog input. So I'm going to use green so we can stay consistent with the diagram. So that will go in line with the leg of the resistor and the one leg of the photocell, and that's going to jump all the way over to, I guess we'll do A0. Alright, next we want to add an LED in here, and that's simply so we can kind of see what our program is doing. So let's use this red one. We're going to go, as before, from the positive leg into the positive voltage, and the negative leg is going to jump into one of these rows on this side of the breadboard. Then we're going to put in our resistor, 330 ohms, and you can drop that either to bridge the same row. Right now mine is in like 17, I guess. So I could bridge across the gap, or I can just go sideways. As long as it's in a different row, the other leg of the resistor, that's all we really want. And I'm going to use the red wire to go from that other side of the resistor all the way over to pin 9. Now, that is going to give us control of the output of our LED if we want to do the gradient fading. Okay, so that's it for the setup. Again, all this can be found in the SparkFun Inventor Kit or guide online, and that's all we're going to need to use for today's demo. You could put a second LED in there. Maybe I will. I don't know if we're going to use it yet, and I'm not too worried about it. Same thing, 330 ohm resistor. Hey, look at that, I got a yellow wire. And we'll take that over to pin, I don't know, 6. All right. Now, one thing I haven't mentioned before is, not that I'm doing too much here, but if you had a lot of LEDs running off of one of these pins or off of one section of pins on the Arduino, you could potentially draw too much current. So just be aware of that. I encourage you to read up on the current limits of those sections. I've never gone over one, but that's also because I've been very careful and used it really just sparingly for this, or using an alternate power source to actually light the LEDs. And we'll get to that in a later tutorial, but for now, this is fine. Okay, well, now that we've done that, let's take a look at what we're programming today, which is, if we go to our Arduino CC website, go to the reference page, switch case. Switch case is a glorified if-else statement, but it's much nicer, much easier to look at, first of all, easier to write, and it can be implemented quicker than if-else statements. So it's a really, really nice setup, and most programming languages have something comparable. So let's go into our Arduino code here, and let's, as always, start with our examples, basics, and bare minimum. All right, we'll close that down. Wonderful. Okay, so what do we want to do today? Well, we want to start with switch case, and as I said, that's kind of an if-else statement. And so in order to do that, first of all, let's get our sensor working. So if you already know how to do this, go ahead. I'm going to move through it a little bit quicker than previously because you have seen this in my previous tutorials. All right, first thing we need is const int, and that's going to be defining our pins. So we've got the light pin, we'll call it, equals that's A0. Const int red LED equals 9. Const int yellow LED equals 6. Okay, again, I chose those values, 9 and 6, because they have PWM, so we can fade the LEDs if we want. All right. Oh, and I spelled const wrong. Okay. Also, int light val equals 0. That is going to be the value or variable to monitor the incoming value of the light at all times. In our setup, first thing I want to do is begin my serial, because we know we're going to be so serial.begin 9600. We know we're going to be monitoring that to get some readings. As well, we want to initialize or define our pins, so we'll go pin mode, light pin, input, pin mode, red LED output, pin mode, yellow LED output. Okay. Also, let's just get practice. Digital write, or I guess analog write. Red LED low. Oh, not low. 0. It's the same thing, but when we use analog, it must be a number. Analog write. So what I'm doing here is that if I restart the code, that it turns the LEDs to off state. Not necessary, but something that is always good practice to do, is initialize your state of your outputs or inputs. Okay, let's move down to the loop. So first thing I want to do is I want to analog read. Well, I want to set up my variable. This is int light val equals analog read light pin. Okay, and then serial.print, let's say light, colon, space, quotation, serial.print line, light val. Alright, so let's review what this does. It creates a variable or reinitializes the variable light val and sets it to the analog reading, which is on A0 of this pin. Okay, so that's going to be whatever value is coming into our photocell. Serial.print, so it's going to print the word light, and then next to it it's going to print the variable, whatever this is, and start a new line. So let's try and upload our code. Let's plug in our Arduino first. Okay. Now, I was previously uploading something else here, and I switched it to the Arduino Pro Mini on a different COM port. So it's going to have an issue trying to upload this, and so I'm going to have to make sure we change that and re-upload it, as it says, not synced. Okay, so when you see this thing, it means that there's there's a number of problems that could be causing it, but essentially it means that you have chosen the wrong board for what you're uploading to, or occasionally this is what happens when you start using the 0 and 1 pins. If you have anything connected to those while you're trying to upload, you might get the same thing. So sometimes you got to disconnect 0 and 1. But I know that this is because I have the wrong board. So Arduino Uno, as well as the wrong port, which is COM3. Upload, and we should see something different happening here. Okay. Now, analog write 0, turn them on, which is strange. That's okay though. We'll take a look at those in a minute. Let's take a look at our light reading. Interesting. So that worked, at least. So what I did with the LEDs is I connected them backwards, and it should be the positive leg going to the resistor, the negative leg going to ground, and that way we can control the positive voltage coming out of the pins. So sorry about that. That's why we do this over and over again. Okay, so looking at the light value, if I bring this and move my hand over top of the sensor, you'll see that it starts to go down. Okay, the closer and closer I get, closer it gets to 0. Now, obviously there's a lot of ambient light in here, which is why we're getting something close to the maximum, which is 1024. It's up near the 800. So if I cover this right up, put my thumb directly on it, we're only getting down to 300. Now I'm just going to cover this up with my hand. Oh, there we go. We're almost at 0. So that is the reading that we were looking for. Okay, and this is what I've used in a number of my programs, especially everyone asks me how I do the triangular element. This is what's in there. It's just one of these tiny little sensors, and laser beams can increase the light even more than ambient light. So I just have it looking for something that's up around the 950 mark is the only thing that activates it. So that's one of the things that I've used this for. Also for my mind reading headset, it just looks for the ambient light. When I put it on my head is now blocking some of that light, and then of course we've got we can initiate something else. So there we go. So we know this is reading. We know that a lot of light in this case is higher, and lower light is lower. Okay. Good to know. Again, ambient light is around 860 for me right now. It's going to be different for everyone. Different time of day, different conditions change that. So keep that in mind, and we're going to show you how to troubleshoot that. Okay. So we've got our light. The first thing we want to do to this, I think, let's map this to one of the LEDs. So let's make one of the LEDs turn brighter as I make it darker. And this is the same type of thing that's happening in your night light. All right, so that's essentially what we want to do here. So let's say this. Let's map our value again. Let's do that. Let's say analog write, I'm going to do this in a little bit of a more coding efficient manner, I suppose, in that it's one line, but it's not nice to work with otherwise. But for this situation, it's okay, and just as a demonstration. So analog write, normally what you put in here is, okay, what are we writing to? Well, we're going to write to red LED, and what value we're going to write to? We usually say a number there. Okay, now instead of, I don't want to write the light val, because if you remember, when we analog write something, the range is from 0 to 255. Okay. Instead, I want to take whatever this value is, and I want to map it to that 0 to 255 range, but in reverse. Okay, because think about it. If I said make this value when it's close to its high, which is 1024, map it to something close to 255, the light's going to turn on when the light is bright, and that's not what we want. We want to reverse that. So watch this. Say map. What are we mapping? What value, what variable are we doing this with? It's going to be light val. Okay, comma, we're going to map it from 0 to 1023. Okay, and we want to map that from 255. This is how you reverse it, to 0. So that means anything close to 0 is going to map closer to 255. Anything closer to 1023 is going to go closer to 0, and everything in between will be figured out by this mapping thing. And don't forget to double bracket, because this is inside of here. So I could have made a separate variable to define this mapping to, but I can also just stick it right in here, and it will do the calculation and insert it into the value for the analog write. Okay, so let's try and upload it and see what happens. Okay, now the light is kind of on right now. Let's look at our variable here. If I cover it up, we should see the light getting brighter, and we do. Okay. Now what's interesting is that it's not really going off completely, and there's a reason for that. And that's because the PWM, it's only around the really low values. If this is about 860, this is probably sitting around maybe 50 for output on there. It's only around like the 10 to 20 range that you really don't see a very bright LED. But even this is pretty bright. And once you get up to around between 150 and 255, it's really difficult to really distinguish between the brightness. Okay, but you can see that fluctuation there. So maybe what we want to do, instead of going from 1023, its maximum range, maybe because I know my highest is 860, maybe we'll say, let's go from 0 to 860 and go all the way up to from 255 to 0. So this should now get us closer to off in this ambient condition. Okay, so two things are happening here. One, it is working, and if I go and block, you'll see it stops doing that crazy flickering thing. But what we are seeing is that occasionally it is getting brighter than 860. And so now that I've mapped it to something where it's going outside the range, it's now taking it directly up to its maximum value. And we don't want that. So I'm going to go in there, I'm going to change that again. I don't think it's going to exceed 870. Let's upload it again. We should get rid of that intermittent flickering. We do see now that it is staying pretty off though for this light. Okay, so that's a lot better. It's still on pretty bright, but as I bring my hand down, we can see the fluctuation. I think a lot better. Okay, well, as I said, before we get to switch case, I do want to cover the initialization of this, because what you don't know when you're using these is what the ambient light value is. So what I like to do at the very beginning in my my void setup, it's always ideal to do this same reading. Okay, we're going to do that up here. And we want to do that multiple times. Now, how many times? Say 10 times is good. So we do a for statement. Int I equals 0. I is less than 9. I plus plus. Okay, and then we open up our bracket. We do the reading. And now what we're going to do is create a variable. We don't want to initialize that variable every time though, so I'm going to do that up here. int and light equals 0. And light, here I guess, and light plus equals. Now I could have written this as equals amb light plus light val. Okay, that would be fine. That would say whatever this current value is, which is when you start at is 0, take that value and add on this value. Okay, now I don't like to write it, take up so much space, so plus equals means take this and add this to whatever this value currently is. Great. And maybe we'll do a delay in there just to give it some time in between each one. I think even delay of 1 millisecond is something. Usually you do a delay of about 10 milliseconds, but because we're going through this 10 times, we're going to get at least some variation there. So that should be fine. If you do find that this isn't giving you a very accurate portrayal, then change that delay value. So that's it. So all we're going to do is, we come for the first time, it's going to run through this 10 times. It's going to take the light value, add it to this. Oh, then afterwards, we want to divide that by 10, because otherwise we're going to end up with something that is 10 times as big as the current light value. So we go here, we say and light, after the for statement is done, divide equals. So take the current thing and divide it by 10. And now that's going to make amb light a factor of 10 less than whatever it was after adding it up 10 times. All right, this gives us now amb light, which is the value that of the current state of the room lighting. Okay, and we checked this at the beginning. You could make this something that you can check outside if you want to recapture it later on. You just have to copy this code and put it somewhere else in there. Okay, so now that we've got amb light, instead of saying 870, I'm going to say amb light here. Now we don't have to worry about what number that is. Hopefully we get something that's accurate. However, I do want to monitor what our amb light value is at the beginning. So actually I'm going to put that before this. Serial.print. Let's go amb serial print and light, and then here I want to make sure we comma space. Okay, so now we should print the ambient light reading, which will be the same the whole time, next to the current light reading, and we can see how those relate. So let's upload, see what happens. And let's go to our... Alright, so it's telling me the amb light is 770. Well, that doesn't seem right, does it? There is definitely another addition affected here. So we're not getting the effect we want on that, which means that my code here was wrong. I should have said less than 10 or less than or equal to 9. Both will accomplish the same thing. Let's try this and see if we get a better number. And that looks a lot closer. So we are getting something that is much more comparable to the current light standards now. And when I go and block it, we can see that that is now ranging a lot better. And we still are getting a little flicker though, because you can see that some of these readings now are going above our ambient light reading. So how do we fix that? Well, you could go down here and instead of just ambient light, we know that it's like only a few digits above what the max was. So all I have to do is in here, I can put brackets or not. It should work either way. We'll say ambient light plus 5. So what we want to do is we want to go to whatever the ambient light value came out as and just add 5 to it, and we're going to map it to that now. And so that should cover that extra little bit of fluctuation that we get in the room. Okay. So let's take a look now. Now we don't have the intermittent flickering. It responds. And if we want to see what that value was, ambient light is 857 now. So we can add the 5 on. It's looking for 862. Some of these are going up too if I stop it. Looks like we're getting 857. 857 seems to be the max here. Oh, 858. Okay, so that would have gone above. So now we've covered that with our +5. Okay, great. Well, that is that's using the photocell. The switch case really just gives us if-else statement that is really nice. So it's really easy to oh, that's not what I wanted. Switch. Okay, we're going to write that down here first. So switch bracket. What variable are you looking at? All right, this is what we're going to be our conditional variable that we're comparing to. In this case, I'm going to take light val. And I'm going to say open bracket. And I'm going to close bracket down here. And within this, we're going to say case. And what cases are we looking at? Okay. We want to know where the light val is, let's say exactly case 400. Okay. And we'll put a colon there. All right. Now the syntax here is a little bit different, but what this is looking for is the case where a specific situation happens. Okay, so when this variable, we're comparing this variable, is at a specific state. Now maybe it doesn't make as much sense for this photocell, but places where this makes a lot of sense is if you have a counter or different modes that you want this to be in. You would say case 1. So when the mode variable is at 1, do whatever's here every time this code goes through. Then you could change this to 1, and then you'd have a separate one for 2, 3, 4. You have as many modes as you want, and it breaks the code up very nicely with one function here. In this case, I'm going to say 400. So when light val is exactly 400, what do we want it to do? Well, this is where we're going to introduce our do while. We're going to do everything at once, or I guess we'll just do our while. Okay, while light val is less than 400. Okay, open bracket. Let's do some sort of flickering of the yellow light. Let's do that. So we'll say analog right, yellow LED 255, delay 50, I guess, just a flicker. Analog right, yellow LED 0, delay 50. So that's going to flicker our thing. And what's really interesting is it's only going to do it while the light is less than 400. As soon as it's not, it's going to come out of this and continue on. Now, there's something really interesting here that needs to happen, though. In this while loop, it will continue to repeat whatever is inside over and over and over again until this condition is no longer true. But guess what? It is not ever asking itself, what is this condition right now? So we have to make sure that inside of the while loop, you are asking whatever this condition that it has to check, you're checking that. Okay, because otherwise it will do this forever and you'll never get to any of your other code. So let's say int light val. Actually, you know what? I don't know why I'm typing it out. We'll just go like this. And we'll copy paste, save ourselves some time. So we just want to check, what's the current light value reading? Okay. Now that's for our while statement. We're still not done writing our switch statement. Okay. So this might be where you say like mode 1, or in this case, if light value is exactly 400. Then do this, okay? Or if light value hits 400, then we will run this while statement until the light value becomes greater than 400. Okay, great. Now we're not done this switch case yet because we have to do something else down here called break. Okay, now break means get out of the switch, because you're going to see we're going to have a separate case here now where we'll say case, and let's try one that's 600. What do we want this to do when the light val is 600? Okay, well in this case I'm going to do a do while statement, do, and let's say let's say a fade, perhaps, of the yellow LED. So we'll say 4. Int I equals 0 to 50. I'll do 0. I is less than 255. I plus plus. Sure. Oops. And all we want to do is say analog right. Analog right. Yellow LED I. So we're just going to write whatever the value is, and we'll delay so we can actually see the fading. We'll delay by 10. Yeah, 10. No, let's do 30. I want that fading to be a little bit longer. Great. And then, boom. So all this is going to do is, okay, when we hit exactly 600, it's going to do this. Now the difference between a do while, let me finish off the, I guess the do while here. This bracket matches up with that one. This bracket is for the for statement. After this one, we have to say while bracket. Okay, what's the while condition? What's the exact same as up here? We want to say while light val is less than 600. Sure. Okay, and then and let me just check the syntax on that. I always forget if we need a where's the do while. I always forget if we need a yes, we do. We need a semicolon afterwards. So after your while here, you need a semicolon. So what this is doing, the difference here is this do, it doesn't check the condition. And don't forget, we actually haven't checked our condition at all, so neither of these would really do what we want. Inside the while, okay, we'll check the condition. Now, the difference is this is going to run this code as soon as we hit 600. This code is going to run, which means it's going to fade through the yellow LED at least once, then check this. If the light is still less than 600, it's going to do it again. If it's still less than 600, it's going to do it again. As soon as it's greater than 600, boom, it gets out, and we break. Okay. So the break, again, is all about getting out of this switch case, because now we have two cases. And what we don't want to happen, if I didn't have this break here, you would see this, this piece of code happen, and then it would do this piece of code. We don't want that. We want it to break and get out of the switch case, okay, which ends down here. And then it will go back to the beginning of the loop and do this all again and check the light variable and see what we've got here, okay. So in this case, this is if light value hits 600. Okay. So the difference again, a while loop checks the variable or checks this condition, and if it's not true, it won't run any of this at all. Only once it knows it's true, then it runs this. In the do while, it'll run this regardless of the condition and then check, and if it's not true, then it continues running again and again and again until that is true. Okay, or until, yes, this condition is met. So let's try that. Let's see what happens. I have no idea if it's going to work. I suspect it will, but I won't know. And what we're going to do to monitor this is use our serial monitor. Okay, so what we're looking at here is, let's do that, and let's make sure auto scroll is on. So we've got our ambient value of 850. As I move my hand over top, we will see that this starts to drop. We should be getting close to 600. Close. Oh, we hit 600. There goes that yellow LED. Fading up. And then, now it stayed on. We didn't tell the yellow LED to turn off at any point. That's because it did the 600 one here. So all it was looking at was, okay, I did it. Hey, look, it's greater than 600 again, so I'm going to get back to running. Now, if we take it all the way down, and we block it, we get to 400. Now we jump past 600 there. I want to get right around 400. You can do it. I'm pretty sure we're hitting 400 there. So why? Because we're not staying on 400. So let's go back to our code. And let's try and put a for statement around this flickering, so at least it will flicker a few times before for us to identify. For int I equals 0. How many times do we want it to flicker? I don't know, I is less than 5. I plus plus. Alright. I presume this is the problem, but we'll find out in a moment. Alright, now we have a for statement in there. It'll flicker it 5 times and then continue checking. And then repeat itself. Upload. Okay, serial monitor. And I'm getting nothing happening here. So as I said, this case 400, for it to be exactly that, it did work for 600, which is funny. Let's see if we get 600 to go again. Yeah, there's 600 works. Now we get the fade on, and it will stay on. 400 doesn't seem to work, and I'm curious as to why that is. Nope, not happening. Okay, so I think the reason why is because when it is 400, it's not less than 400, and I think that's our problem here. So what we need to do is we need to check, and this is I guess the main issue with the while and do while. At least the do while will go and then it checks, right? That's where I put the checking in. It's going to run this while, but it's looking for if it's less than 400. Okay, so we'll never do that first one because this is always going to be exactly 400, and there's our problem. Okay, so in this case, if it's less than or equal 400, this will run because we know it's going to be 400 the first time, so it will run, and then we'll continue to check if it's still less than 400. So let's go upload. We should get the effect we're looking for now, and this is why it's important to debug and check the difference between while and do while. Make sure that it's doing what you want. So here we go. Let's get all the way down to 400, shall we? There we go. As long as this is less than 400. Now notice we're not printing anymore because we don't have that print inside of the while statement. So it's just going to keep holding off there. We know as soon as I move away. Oh, it's repeating a few times there. Okay, now it's still going and I don't see anything else printing here. So that tells me that we're stuck in this loop. Now, why are we stuck in this loop? Let's see. Int light val equals this. So it should be reading the light value as it runs through here. This is running from 0 to 5 and it's flickering. So it should come back and the while should repeat. The analog should be greater than that right now, and yet we are not exiting the loop. Okay, so that's a good question. Let's find out why. Let's put a print in here. Some print statements like so. Don't need the ambient light reading. We just want to see these. Okay. Oh, I guess we want to put that inside of the... Oh, let's try it here. That works. Upload. We're close. Okay, here we go. Get it down to 400 again. Okay. Okay, now light is greater than, and yet this while continues to go. Let's go check and make sure I've got the syntax right, but I'm pretty sure I do. Wow. Yep. Right. So the light value is greater than, yes, okay. We got break, it's fine. Interesting. So I'm not 100% sure why that one's not working. We do know that the do while does work. And I'm going to take some time after this to figure it out. But this is really what I want to show you, is that there is advantages to using each one depending on the situation. This one will do it once and apparently will never stop. Whereas this one also will never stop unless you put it in that condition as to what it should be looking for. Okay. All right, so I think that was it. I've covered the switch case. I've covered do and do while, and while and do while. And for the next tutorial, we will be making your own functions to do stuff like this without having to place it all over your code. So functions are awesome. We'll be covering those next time. If you have any questions or comments, please post below. As always, thanks for watching. This is the real Tony Stark, signing off.